Hi, I am Arib. You are watching my YouTube channel. Lockout Relay. Definition and purpose of lockout relays. Lockout relays, also known as lockout devices, are critical components in electrical protection systems. Their primary purpose is to isolate electrical circuits in the event of a fault condition, preventing the re-energizing of the circuit until the issue is resolved. This ensures that the fault does not cause further damage or pose safety risks. By locking out the circuit, these relays protect both the equipment and personnel from potential hazards. Lockout relays function in electrical safety systems. Lockout relays play a crucial role in maintaining electrical safety by detecting and responding to abnormal conditions such as overcurrent, short circuits, or equipment malfunctions. When the relay detects a fault, it activates and interrupts the power supply to the affected circuit. This immediate action prevents further damage to the system and protects personnel from potential hazards. The unique aspect of lockout relays is their ability to maintain the circuit in a locked-out state until manually reset by an operator. This manual reset mechanism ensures that the circuit cannot be inadvertently re-energized, which is critical for safely addressing and resolving the fault. The locked-out state provides a fail-safe method to manage electrical faults, ensuring that the fault condition is thoroughly investigated and rectified before restoring power. In practice, lockout relays enhance the reliability of electrical systems by preventing recurrent faults and minimizing downtime. They are integrated into various safety protocols, ensuring that any detected fault triggers an immediate response, thereby safeguarding both the equipment and the personnel. Regular maintenance and testing of lockout relays are essential to ensure their proper function and reliability in critical safety applications. By understanding and implementing lockout relays effectively, engineers can significantly improve the safety and reliability of electrical installations, preventing accidents and costly equipment failures. Key features and types of lockout relays. Lockout relays are equipped with features that enhance their functionality and reliability. One key feature is the manual reset mechanism, which ensures that once a fault is detected, the relay can only be reset manually. This prevents accidental re-energizing of the circuit, ensuring that the fault is properly addressed before resuming operation. Another important feature is the fault condition indicator, which provides a visual or audible alert when a fault has occurred, aiding in quick diagnostics and response. There are two main types of lockout relays: electromechanical and digital. Electromechanical lockout relays use mechanical components to perform the lockout function. These relays are known for their robustness and reliability in harsh industrial environments. They are simple to operate and maintain, making them a popular choice in many traditional setups. For those interested in robust electromechanical options, an electrical relay switch can be a reliable choice to consider. Digital lockout relays, on the other hand, offer advanced capabilities such as remote monitoring and diagnostics. They provide improved precision in fault detection and can be integrated with other protective devices within a smart grid or industrial automation system. Digital relays also often feature programmable settings, allowing for customized operation tailored to specific application requirements. In summary, the selection between electromechanical and digital lockout relays depends on the specific needs of the application, with each type offering distinct advantages in terms of functionality and integration capabilities. Proper understanding and implementation of these relays can significantly enhance the safety and efficiency of electrical systems. Conclusion: Lockout relays play a vital role in enhancing the safety and reliability of electrical systems. By providing a robust mechanism to isolate faulty circuits, they prevent further damage and protect both equipment and personnel. Proper installation, configuration, and maintenance of these relays are essential to maximize their effectiveness. As industrial systems continue to evolve, the integration of advanced lockout relays will be crucial in maintaining safe and efficient operations.